Okay, in this video we're going to look at our next set of HTML basics and pick up where we left off after part 1. As a preview, these are all things that we'll look at here with examples. So formatting, bold and italic and so forth, quoting, comments, tables, and lists and symbols. And we're under the HTML Basics Part 2. These are the list of the sections that we're going to look at from here. We'll just sort of skim past them, but then again do an example. And we're going to skip over anything that has to do with styles. There's a bunch of these that have to do with styles, which is how things look, and we'll wait to do that for a little bit. Alright, so we're going to go over to the server. So again, we're going to connect into the CS server. I'll do this in our class directory. Copy empty, and I'll call it basics2, and the example that we do this time is some math. Some of this math that we'll need anyway. We'll use this as an example. Okay, so this is our page. I'm going to call this example of basic HTML and some math information. Okay, and just to get started correctly, I want to make sure this validates. I don't have any syntax errors. And I want to take a look at what it is. Have to make it readable. Okay, there's basics2. That's what it looks like. Nothing right now. So every once in a while we want to make sure it validates. Looks good. Okay, so we'll start typing up some of the information, and this is math information that you want to know anyway, and then we'll put it in. Okay, so I'll just type like this, and then we'll see how we want to put it in. So information about rules of exponents. Okay, if you have the number 2 raised to the 3rd power equals what? 2 times 2 times 2 equals 8. Okay. Now if I want to write that in HTML, then you might be tempted to do something like this, because you might be able to do something like that in a calculator or a math program, but that's not correct here. So in HTML, there's a superscript. And I can look at this over here, and we're seeing that we need to put in some tags. So this looks like how we think it should look. Okay, rules of exponents, 2 to the 3rd equals 8. Why don't we call this powers of 2? These are things we should just remember, and I'm going to maybe make a list of these. So instead of putting just multiple paragraphs, I'm going to make an unordered list. Okay, so that's a new thing, an unordered list, and I'll do, so 2 to the 1st power. Let's start with 0. 2 to the 0th power, what is that equal to? Do you remember from math? You multiply 2 by itself 0 times, you'd think it would be either 0 or 1, and it ends up being more convenient to call it 1. 2 to the first power is 1, 2 to the second power is 2, or 4. We'll go 2 to the fourth is 16, that's an important one, and we'll just skip to 2 to the 8th. Does anybody remember what 2 to the 8th power is? In computer science, this ends up being fairly useful to remember. And the last one I'll put here is 2 to the 10th. 1024, which is close to 1,000. Okay. So there's what that looks like. So now we have sup for superscript, ul for an unordered list. So we make an unordered list like this, and then inside of it we have li for list item, powers of 2. Okay, now we'll do rules of exponents. Now that we can do powers of 2, and I'm going to make this an ordered list. So an ordered list is like an unordered list, except it'll be numbered. Okay, so if I have some numbers x to the power a, and then the quantity of all of that to the power b, where these are just some numbers. Okay, x to the, I have one extra parenthesis. Okay, so x to the power a to the b, does anybody remember what that is? So x to the a means you multiply x a many times, and then you take that thing b many times. If you work it out, you can do some examples. That is x to the a times b. And right now I'll just put a times b like that. We could use a different symbol for the times, but we'll get there. Okay, so that's one rule. What if we have x to the a times x to the b? Okay, so this x, we could have 10. A could be 2, 10 squared. And we could have 10. B could be 3. So 10 squared times 10 cubed, what would you get? And we could work them out. We can do examples of this sometime later, but right now we'll just write them down. The rule is like this. Okay. There are other ones we could make. Let's just make sure this all validates still. It still validates, so at least we haven't made any of those types of mistakes. Let's put another rule here. X to the a plus x to the b. Alright, so what could we say about that? Let's assume a is greater than or equal to, I don't know if that works. Assume a is at least b. Okay, so if a is at least b, then we could do this. This is something we could do. We could factor out a b. And then we would have on the inside x to the a minus b plus 1. I guess we should put the times there. Alright, so those are 3 rules. We could make up others, but that is an ordered list. For an ordered list, we can change the type by adding a type attribute. So if we do lowercase a. It looks like that. If we do uppercase a, it looks like that. We could do a 1. That was the default here. We could do lowercase Roman numerals, uppercase Roman numerals. Maybe there's some others as well. Why don't I do, I don't know, lowercase Roman numerals. Okay, that's something. Now let's go with hexadecimal. And there will be a reason. So hexadecimal is base 16. Also known as base 16. So you may remember base 10 has 10 digits, 0 up to 9. Okay, base 16 has 16 digits, single characters that represent a number. So we have 0 up to 9, and then A, B, C, D, E, F. If you count that out, that's actually 15. Okay, let's see how that looks. Alright, there we go, that's fine. Let's make that out into a way that's maybe a little easier to look at. So I'll make a table. And in my table I'll have a row at the top, which will be, what I want to put here is 0, 1, 2, 3, and so on. But, so I'm going to have 16 of these. 6, 7, 8, 9, 10, and then I'll put the next ones. Okay, so I'm going to put there the, let's see, and I'll put one more that I'll look at in a second. So probably won't look like much until I start putting stuff in here. It looks like nothing so far. Alright, so let's put in here 0, 1, and notice that, okay, so this TD is for table data, TR is for table row, and each table data item has a begin tag and end tag, and then in the middle should be some text. Okay, so there's 0, 1, 2, 3, and these have to be matched up just like any other HTML tags. If they're not matched up with a begin and an end tag, there would be a problem. Okay, so those are the regular decimal digits, and then in hexadecimal we add A, B, C, D, E, A, B, C, D, E, and F. Okay, so that's 16 extra, or 6 extra. So I'm going to put a label here. Hex digit, and then we'll have decimal value. Okay, right now the decimal values are not filled in. For the first ones, I'll just copy and paste this, take that as a starting point. So for the regular 0 through 9, those are fine, but then if we write down the letter A in a base 16, what do you think the value of that should mean? 10, probably you will believe, and then B would be 11, C is 12, D is 13, E is 14, and F is 15. So if I go and ask Google what is 15 in hexadecimal, it'll tell me F maybe, if it knows that. Okay, so Google knows that. There's a table. It doesn't look very exciting. Let's see if we can put a border on it. There's something we can do, so at least there's a border. And maybe the hex digit, we want that to be, so that's the name of what's happening. So I'll make that strong. And strong is a tag that we can see what it looks like here. It's basically doing bold, but it's a descriptive thing rather than a formatting thing. So there's also B that we can put here for bold. It actually will look the same in most browsers, but strong is preferred because it tells you what the text means, which is what HTML is supposed to do. Okay, so we have lists, tables. Let's do another section here, H2, some formulas, or formulae, sum of an arithmetic progression. This is something that often comes up. And we get to use a new tag called blockquote. So I would say 1 plus 2 plus 3 plus so on up to some number n. There's a formula for that. And the formula happens to be n times n plus 1 divided by 2. You can work it out, do an example. If n is 5, then you'd be 1. Just put the example here so you'll have it. Of course, you should do this yourself. So, for example, 1 plus 2 plus 3 plus 4 plus 5 equals, if you work it out, you get 3, 6, 15, which is the same as, if you did the formula here, you'd have 5 times 6 divided by 2. Okay, so but we have this block quote now. Block quote basically quotes whatever's there. And if it was multiple lines, then this would all be indented here on the left and on the right. The sum of an, so I'll make it look longer. It's something you should know, should remember, because it comes up sometimes in analysis of programs. That's true. Okay, and if, let's see, we'll do here. So if I made this page narrower, so if this takes multiple lines here because it's wide enough, there's indented here and there's also indented here. That's a block quote. Someone once said, there's everything is awesome. So there's also a not block quote that basically just puts quotes in. You could put quotes in, but but that puts the nice little characters. There's a different begin quote and end quote symbol, and you don't have to worry about that if you use the Q. Okay, let's take a look at our list here. So we have strong and B, EM, and I. For formatting, you want to guess what I does? You would probably guess correctly. It does italics, and we typically would use that in HTML to give emphasis. So EM, some random junk, let's say. Well, let's do it like this. So we'll put the I on the N here, and EM does the same. See if it looks the same on our formula. So there's an italic I, that's emphasized because when in math textbooks, normally variable names are italics. There's also, I believe, a var code that specifically means a math variable. In general, that's probably going to display the same, but if Google is looking at your document, it'll know what var means. Okay, so we've got italics. Okay. Insert, delete, small. We've got sub. Let's go back over here. Someone once said that, and also everything is stupid. Okay. So if stupid was there, let's see. Everything is awesome and everything is stupid, but if that was a mistake, but we don't want to take it out of the file, we can put the del. And if we want to put something in that looks like it was inserted, everything is okay. So that may look different, and here it's underlining it. So now if you had some text here and you put something new in, it would underline that, and also Google would understand it to mean that that's something that's new on your page, and it may show up better on search results. Sub, let's look at some rules of exponents, and let's say logarithm. So logarithm is something that maybe people don't know, but I'll just use it as an example with sub. So log sub is for subscript, base 10 of, let's say, 1000. So what the log is supposed to mean is this is called the base. So 10 to what power equals 1000? Answer is 3. Okay, so the logarithm of a number, the logarithm of 1000 is going to be something that is small. Logarithm of 1000 is, then you raise 10 to that power to get it. Okay, another example in computer science will often care about 2 because of, well, we'll get there. So log base 2 of 8 is, so the way you read this is the log base 2 of 8, but what that means is 2 raised to what power equals 8. That's 3. Okay, so then we have subscripts and superscripts, very useful with math. That's good enough for the formatting. We have quotes, site, address, and abbreviation. I'll let you look those up in the W3 schools. Mostly you want to know that they're there and they're available. Comments are important, and so I'll mention this here. comment is not displayed. And the rule is that you have a less than exactly this and then ended by exactly this. Anything in between is a comment. If I go and look at my page, that doesn't show up anywhere, although if I look at my page source, it is in the source. So Google knows about it, and if a programmer looked at this web page, they would see that. So typically comments are there left by programmers. You might have something, copyright statement, web page by Jeff Kinney, last modified 2017, edited. Or you might have some information like that. It doesn't need to be displayed, but it's there in case a programmer looks at this. Alright, tables. There's some other things we can do with the tables. Let's see if we have a reason for that. Lists, we did. Okay, so another table example. So there's one table. Now, I don't know. Alright, we'll do a multiplication table. I think. Why don't we do a exponentiation table? That'll keep us from making one that's too big. So I'm going to have a table and a table. TRs for row and TR. I can have a caption here. A table of exponents. Fun. You can see what that looks like over here. So far we have not a lot. Let's put the border on because that's easier to see what's going on. Nothing much so far. Okay, we need to put some information in here. So up here I'm going to put, instead of TD, I'm going to put TH, which stands, it's like TD, well, I'll write TD and then I'll change it. So I would put here exponent base. Let's see, how do I want this to be laid out? Why don't I type it here in a comment? Okay, so let's say I want it to look something like this. So I have 0, 1, 2, 3, 0, 1, 2, 3. And if I want this to be my exponent, and this to be my base, so what I'm thinking about here is, okay, 0 to the 0 power, I would put that in here. What is that? 0. Well, 0 to any power is going to be 0. And then we'd have 1 to the 0 power. Well, any power, anything to the 0 power is going to be still 1. 1 to the 1 is 1. 1 squared is 1. 1 cubed is 1. Now let's go to 2. So it gets a little more interesting. 2 to the 0 power is 1. 2 to the 1 power, that means 2 multiplied by itself with just one copy. That's 2. 2 squared, 4. 2 cubed, 8. 3 to the 0 power is 1. 3 to the first power is 3. 3 squared is 9. 3 cubed is 27. Alright, I want my table to look like this. So this is my first row, is looking like that. This is my second row, is looking like that. So really my first two rows are doing that. And it looks like I have an empty cell in the first column here. So if I want it to be laid out like this, then there has to be a spot here so that it'll look like this, if that's what I want it to look like. Alright, so that'll just be empty there, and then an exponent, and I'll go up to, let's say I do go up to 2, 3. Alright, and then my next row here, I have the base, and then there's nothing else. So there's the base, and then there's a spot here where I had exponent, 1, 2, 3, 4, 5 cells that would be empty. But instead of putting 5 TDs, I can say call span equals 5. So that'll be a single cell there that goes across and makes it all line up correctly. Alright, and then I would be on to my regular case. So TD 0, and then I'm going to put an empty 1 so that exponent kind of looks like that. And then the values, which are just zeros. There's 4 of them. And that's a row. And I'm going to go down to 0, 1, 2, 3. 1, 2, 3. And I'll go 1, just copying these values that we already figured out. Of course, there are easier ways to make this table, but this is what we know how to do so far. Okay. Let's see. That kind of looks okay. It might be better, actually. It'll maybe look better if we have that call span equals 4, and then we have an empty TD here. So that looks like that. And then maybe on the 0, we'll have a row span equals 4. And then I don't have to have these extra TDs here. So if we're going to have one cell that takes up the amount of space of a certain number of rows or columns, there we go. If we want the top to look a little bit nicer, these get changed to TD, instead of TD, that's table data. Change TD to TH. TH is for table header. I'll just change the ones up there. And that typically bolds them. I suppose I could put the same thing on the base. Let's just leave it like this for now. And there's our caption. So the caption is longer, actually wider than the table. So if I went out here, why don't I go out one more, 4, and then I would have to add, this would go for 5 columns, and then I have to add the fourth power for all of these. Okay, so there's other things we could do to make this look nicer. That's not for today. So the last thing we want to look at today is the symbols. So that is, we're skipping past a bunch of stuff here. All of this, most of the stuff we're skipping here is about style, which is how the page looks. And so far what we've been doing is what the page means. So we prefer to use strong rather than B because strong says what it means. We prefer to put INS for insert. Okay, so we're skipping over the style stuff for the moment and we're going down to entities and symbols here. Okay, so we already saw an example where we can't actually use a less than in HTML code. Let's check to make sure what I have here still validates. It doesn't. There are some warnings. Some of them could be real problems. Let's ignore them for now. If we certainly, if I try to put something like things that are true, and I'll make a list. Okay, so I want to say that 1 is greater than 0. That's something that's true. The problem with this is that greater than is special in HTML. So the page may display correctly, or it may not. The problem is you don't know how it'll display because there's an issue. That should show up here. Let's simply look back here. So what we're supposed to do, instead of having the, I suppose the greater than is actually, let's put it this way. If we say less than, we say it like this. Let's see if what the validator says. Okay, so now it's definitely not liking that. It's actually worse to use a less than a greater than, because the less than means it's the beginning of a tag. HTML says I'm beginning a tag, but you're actually not. So we have to use a code, and the rule in HTML is that you have codes that start with ampersand and end in a semicolon. And there's a list of them, so they normally make sense. There's less than. Now, we know that less than and greater than are special, so we should never type them in HTML. But now we have another issue that we just use ampersand in a special way. So ampersand is actually special as well, and it has a code that's like this. Okay, if I go back and look at this, ampersand is used in HTML. The semicolon, on the other hand, is okay because notice that semicolon is okay because it's not the start of anything special. If you just have a semicolon in the middle of nowhere, it doesn't think I'm doing anything special. If I just put an ampersand somewhere, it thinks I'm doing one of these special codes. Okay, now what if I want to do a copyright symbol? Copyright symbol is what? There's a code for it. In Word, you would go and insert your symbols. In HTML, copy may be it, but you normally want to check that to make sure. So there's a list of common ones. Generally, if you're trying to do something that's not on the keyboard, you go and look it up. So accents, foreign words, symbols here goes on to more. There's some math symbols. So I could say in math speak, let's see, there exists infinitely many prime numbers. That's something that's true. This is a math symbol that means there exists. Okay, and you can get a list of ones that are commonly used. There's Greek letters, which the usual things are probably going to work, what you would expect. That's probably going to work for lowercase pi, but you would have to check to make sure. 5, 2, 6, let's see, 1, 5, 9, 2, 6, 5, 3, 5, etc. All right. Okay, and there are various lists that you can get. There's a link in the document here to a somewhat full list that you could look at sometime to view all things that are possible. Most of the things that you can do in Word, there's an HTML code for. And if we just zoom in on one of these here, that's not looking very good. Let's see. Go back up. Let's open that up again. Let's see. Aleph. Okay, so the way this is the code that we'll use with the ampersand. So I could say Aleph is a symbol. And then we could see how it displays. Okay, so that's stuff that we know how to do now. And that'll probably be it for basics. Have a couple assignments, and then move on from there.